Okay, so what we're going to do is we're going to talk about sections of Chapter 4, not the whole thing. If you look at the assignment, it's 4.1, 4.4, 4.8, 4.10, I think it is. But anyway, I've got the notes over here. So we're going to go through sections of Chapter 4, and we're talking about requirements. Now, we've mentioned requirements many times, but this is going to get into more depth on classifying them and handling them after the fact. So, here is what Chapter 4 looks like. So we're going to cover the requirements process, then we're going to skip down to 4.4, types of requirements, and then 4.8, requirements documentation, 4.10, measuring requirements. And that's where we're going to stop tonight. And then next week we'll cover the rest of it, and Chapter 6, I believe, is on next week's agenda as well.
So is there no 4.3?
There is no 4.3. Yes. That's a bonus.
Okay. We have to complete 4.1 and 4.2 before we'll unlock?
Yes. So eliciting requirements from the customers. In other words, asking questions, collecting their requirements. The key is that the customer knows what the requirements are, but that we need to put them into a form that we can actually act on. So it's not just a matter of taking a tape recorder in and start saying, what do you want to see? How do we model requirements? Modeling them so that we can address them. Reviewing requirements to ensure their quality. A requirement that we have seen before and we definitely understand how to do, well, that's a pretty good requirement for us, isn't it? A requirement that we read later and we say we have no idea what that customer was saying is not a good requirement. Okay? So documenting requirements for use by design and test teams, because they may not have been the people that actually talked to the customer. So they need to see something that is succinct and they can work with. So what is a requirement? It's an expression of desired behavior. Well, that's pretty obvious, but we need to think about that. That's really what it is. When you talk to a customer, it helps to let them know that that's what you're looking for. Requirements are not necessarily a customer telling you what the screen ought to look like, or to tell you what programming language they want to see. The requirement from the customer standpoint is, we're building something, what should it do for the customer? It deals with objects or entities, the state that they can be in. So if you're looking at entities in a file, what state are they in the file? Are they already in the file, or do we have to gather them and put them in the file? Are they in another computer and we're interfacing with it? Or are we interfacing to another computer? So all of that has to do with the state that they're in. The functions that are performed to change the states or the object characteristics. So that's as we're asking questions. We need to ask them, okay, so you've got the customers over here, but what is it you really want us to do to those customer files when we're feeding them through our system? Are we updating the amount they owe at the end of the month? What are we doing? Again, they're focusing on the customer needs, not the customer file, our customer. People are giving us the requirements. Not on the solution. We're going to figure out a good solution for meeting their needs. We don't want to have them telling us what the solution is, or necessarily the implementation. Now, is that ever not the way we do things? Well, when you're brought in, you're probably brought into an organization that has a certain set of solutions that they want to see you use, and maybe a way that they want you to implement it, because you may have IT people actually giving you the requirements. But we're talking about an application here where users are not necessarily IT folks. Okay. So, again, we want to designate what behavior without saying how that behavior will be realized. What do we want to get out of this, not how do you want us to do it? That's our job. Okay? So what are some of the top factors that cause projects to fail? I think we've looked at these before, but I think they're interesting to go through anytime. Incomplete requirements. Somebody that says 5 months into the project, oh, we forgot to tell you, we also need this, right? Lack of user involvement. The users give you the requirements and then they go away. And when you say, look, we need these update sessions, they say, well, we're awfully busy, we can't do that right now. Okay? So you need the users always to stay involved, not in watching what you're doing, but watching the results that you are producing. So the prototyping and all those kinds of things, you've got to have them involved to look at that work. Unrealistic expectations. We need to watch out for those. When you are interviewing for the customer requirements, you can probably see unrealistic expectations. There's a tendency among technical folks to think, I'll be able to figure that out. Don't. If it's unrealistic, tell them it is. Lack of executive support. When you have the baseline users making all the requirements and you don't have the executives, you're going to have problems where they're asking for something that's well beyond the budget that the executives think this ought to cost. And later, when you sit down with the executives to explain why we're beyond the costs, you say, well, we had to do this, we had to do, and they'd say, you didn't have to do that. I could have told you, though, that person's going to ask for the moon. We don't want to do that. Well, don't find that out later. Find that out early. Changing requirements and specifications. That's kind of obvious. You don't want them changing after you've collected requirements and gone into planning. And what if you didn't do the planning and just start coding? And what if you get so far into it, you're well behind schedule? This is what really hurts us. You get behind schedule and the executives come down and say, hey, you know, we don't need that system anymore. So time to market is very similar to any merchandising type of thing. It's the same thing with programming. If you drag it on too long, somebody's going to say, we're not hot for that anymore. Okay. And notice that although this doesn't look like requirements, this may not look like requirements, that may not look like requirements. There's an essence of requirements in all of those, because requirements drives the project. If you don't do the right job with requirements, these other things can happen. And the other thing is the requirements error can be very costly if it gets down to where you've actually implemented something only to find out that that person that said that was a requirement did not have the authority to say that, and the executives say, no, we don't want that. So, as usual, we have a chart. What you want to do is you want to have the meetings with the users and elicit their requirements. Then you go back and you analyze those requirements, and we're going to show some analysis here in a little bit. Then you set specifications based on that analysis. But while you're doing the analysis, you should be going back and talking to the customers again and saying, did we analyze this correctly? Do we understand you correctly? Okay. This may be where you do some prototyping. You build specifications, and then you want to validate what you've done, because this is fairly structured at this point. You're almost ready to go to the coders. So you want to go back and validate with the customers before you go on. And then you create the software requirement specification, which this goes into the design. You know what tightly coupled is?
Strongly dependent on each other.
Tightly?
Oh,
Tightly coupled.
tightly.
It's misspelled tightly coupled, that's what it is. You're absolutely right. If requirements are tightly coupled and complex, This could be rather heavy and complicated, okay? If the requirements are uncertain, agile methods are an alternative approach. We talked about agile methods, right? I was talking to my friend over the weekend, I think I mentioned to you, works for one of the big carpet companies. And they have, right now, said, we're going to agile methods. And the reason is they're going into a new plant with new equipment and new technology. It's a whole different world. And they cannot say the way it ought to be. There's going to be things coming up as they start learning. So agile methods makes a lot more sense because you can dance, you're quick on your feet, right? You do only what's needed for this particular module, and then you make it possible to go build another module. Modular design has a good tie-in with agile methods. So you gather and implement the requirements in increments, and those increments can be actual modules, separate modules of code that feed each other. Extreme programming, kind of like extreme sports, it's an agile method, but the requirements are defined as we build the system. That seems to be anti what we were just talking about, doesn't it? But it's when things are critical time path-wise, you've got to get this out. But you got the best people, and they know what they're doing. No planning or designing for the possible future requirements. Just keep it simple, do whatever we need. Know that if we need to do something in the future, we need to come back and modify. It encodes the requirements as test cases that eventually implementation must pass. So what we do is we take the requirements and we actually plan to those individually as test cases. And as we're going through our testing phase, we use those requirements as our tests. Okay. So, we go to 4.4. All right, so these are things that you want to make sure you have in your requirements. First of all, you want to make sure they're correct. And to tell you the truth, I keep getting on this point because I guess I saw it so many times. Always make sure before you go forward with your requirements specification that you've gotten the executive in the room. Run those by him. Make sure those are correct. Make sure they're consistent. You don't have two requirements that are clashing against each other. That if we did this, we couldn't do this, and vice versa. Fix those immediately. You cannot have ambiguous requirements. If somebody reading your list of requirements can't understand them, you probably need to go back to the customers and clarify them. Or rewrite them if you know what they are and it's just not written well. They've got to be complete. You can't have any holes. They've got to be possible, feasible. Make sure you can do it. Make sure they're relevant to the customer's needs. If there's a requirement in there that's not relevant to the customer's needs, somebody wants to make sure that the background's purple, you may want to just drop that for now. Make sure that's something later. Make sure that you can actually test when you get to unit testing and systems testing especially, that you can test to make sure you're doing the requirements. And make sure that the whole thing is traceable, that you can show that then in this module here we're doing or meeting this requirement. Okay.
The testable part is what gets left out a lot.
Yeah, yeah.
We're
We're running up against the deadline, no time for testing. Yeah, we'll let the users test it. That's not a good way to win them over. Okay, that is 4.4 and 4.8. Make sure of that. Okay, so 4.8. So how do we build the requirements definition? The steps within the documenting process. So we're going to outline the general purpose and the scope of the system. Relevant benefits, objectives, and goals. So this is kind of what you were given when you were hired to build this project, right? This is a high-level story about what is it we're building. Are we building a payroll system, and what is it supposed to do, right? And, you know, a story, what's the background of this? Why do they need one? What happened in the business or in the entity that made it necessary to build a new system? So what's the background? And what's the rationale? Rationale includes how they can afford to do it, right? What do we need to do to create an acceptable solution? So we need to describe, maybe with bullets, what things have to happen for this to be an acceptable solution. And what's the environment in which the system will operate? That includes what hardware is it running on? Is it multi-site or is it in one location? How many users are there going to be? How many other systems are we interfacing with? What's our proposal to the customer for doing this? What if the customer has a proposal for solving the problem? What's our proposal to meet that? And what assumptions are we making about the way the environment behaves? Those ought to all be in our documentation. As we're doing this, notice it's the exercise of doing this, not just the paperwork in a book on the shelf. It's actually the exercise of doing this gets us clearer as a team on what it is we're doing, and when you start asking yourself questions about any of these things, you may have to go back to the customer and clarify it, and you better do it now. So what are the inputs and outputs in detail? So what are the sources of the inputs? Normally we keep thinking that the user is going to be sitting at a keyboard putting in data, right? Maybe there's an existing system and we're reading the database on that system as input to our system. So we need to know what those are. Maybe it's multiple systems. How about what's coming out of our system? Where is it going? Is it going to a printout? Is it going to a file? Is it going to another system that must be processed? In which case we've got to make sure that we format the data that can be read by that system. What are the value ranges? Everything we do has a range of values, right? If it's a string, how long can that string be? Is there a limit? If it's a value, is there an upper limit to that value? You know, in payroll, do you want to accidentally cut a check for $1 million? I don't think so. You might want to put a limit on that. There's a story about Oracle for many years, because Larry Ellison was president of Oracle. Anyway, he didn't like cutting checks to employees for more than $10,000. Oracle reps make lots of money. So Oracle reps used to get $5,000, $10,000 checks at a time. And they were mixed in so that he didn't see the name repeating. And he'd sit at his desk and sign. Now, he didn't really care, but he did. It was just his little idiosyncrasy. He just didn't like signing checks for more than $10,000 or whatever the number was. What about the data format for inputs and output data? Remember the area on 4, area on 5 problem? The data format? Okay. In that case, the units. What about protocols for the data? If we're bringing in data from a DB2 system and putting out data to a Teradata or some other database, there may be data protocols we need to be aware of. The window formats, this ought to be straightened out within the prototyping that we're doing, but we want to make sure we know what they are and how we're going to organize the windows, which window comes after which when we build our tree. Is there a timing constraint on doing any of this? Let's make sure that we know it. So what if we restated the functionality of the system in terms of its interfaces, inputs and outputs? In other words, we go to the DB2 system and we input this metadata, or this data based on this metadata. We do this to it and then we output that. Okay? So we want to be able to restate our product in terms of that. And again, we want to devise a fit criteria for each of the customer's quality requirements. They have quality requirements on, if they are Amazon, for instance, they have quality requirements on what the user sees on the screen, right? Because your user experience at Amazon is going to determine whether you use Amazon next time or whether you go to, who's Amazon's biggest competitor?
Walmart.
Walmart, yeah. Walmart and Amazon are the two biggest online merchandisers. And I heard today Amazon is now going to get into auto parts. They're trying to expand what they're doing. They already are into groceries, as you probably know.
That's not good.
But auto parts.
Oh,
Auto parts, yeah. What do you
I
think?
thought you said auto carts.
Oh, auto carts?
What's it?
Oh, that'd be a good idea too. Maybe we ought to ask them. We ought to send them that as a suggestion. Yeah, auto parts, because you can imagine mechanics today, when I go to get my car fixed, in the garage, they've got keyboards, and they're doing all kinds of stuff, right? What if they could just go to Amazon and say, I need this part for this car, and boom, it's going to be UPS tomorrow. Yeah.
Unless you have Prime and it's same-day delivery.
Prime with same-day delivery. Yeah. From Korea? By drone. But anyway.
Details.
Amazon, you don't know where it's coming from.
We'll let the engineers figure that one out.
Yes, exactly. So, one of the problems, we looked at the problems earlier about management involvement, all those different things, right? Well, we also find that problems and requirement specifications are due to uneven level of specification. So, as we're looking at it, and we're getting our specifications for requirements from several sources, these things can happen. We can have different writing styles. That's not titles, that's writing styles. The difference in the experience from the different analysts who are talking to the customer. Sometimes we call these people analysts. Okay? The difference in experience between the different analysts, because they might be going to different departments of the firm. These could be large projects. Maybe they have different formats for the way they're collecting those requirements. That's why we use these forms like you were working on earlier. It's why we do these types of things, to try to get some consistency in our view of what we're looking at. Maybe we've got people that are over-specifying their requirements. Like, here's a requirement that we pay a customer, or we pay an employee on their check, but by the way, we want to have the payment in number 10 pica, and we want to have the name and number. You don't want to have all that, right? That's maybe over-specifying. On the other hand, you don't want to under-specify either, so it's vague, and we don't know for sure what they want. So, how do we reduce unevenness? Write each clause so that it contains only one requirement. Okay, so isolate the requirements. Avoid having one requirement refer to another requirement. That's a little hard to do sometimes, right? Because sometimes it's building on another one. but try to get it to be an individual one-line requirement. And then collect similar requirements together. And this begins to get a cohesive set of requirements. So, there are two types of environmental behavior. Remember, environmental is the existing hardware, people, attitudes, all of that goes into environment. There's the desired behavior to be realized by the proposed system. That's new stuff. But we also got to look at existing behavior that is unchanged by the proposed system. And we've got to make those cohesive. They've got to work together. Yeah, most requirements writers consider the assumptions to be simply the conditions under which the system is guaranteed to operate correctly. It's more than that. We need to look at how are things done today, how is our behavior, or what behavior is going to be unchanged by our proposed system, and how are we going to make all that work together. So, this is the IEEE standard for an SRS. Remember, that is the specifications for the software specification document. So we do an introduction to the document, purpose of the product, scope of the product, acronyms, abbreviations, definitions, references, outline the rest of the SRS, general description of the product, and so forth. I won't go through all of that. But notice that we have a standard, and that's the most important thing. You want to work by standards. Standards sometimes are evil things in our mind because they're kind of like regulations, right? But standards can also save us. So if you take the time to work by the standards, you're more likely to have an acceptable product at the end. So what is process management? It's a set of procedures that track the requirements, define what the system should do, the design modules that are generated from the requirements, the program code that is implements of the design, the tests that verify the functionality of the system, and the documents that describe the system. Well, we've been through this several times, haven't we? But this is the total life cycle. What's missing? Ongoing maintenance. But anyway, it provides the threads that tie the system parts together. So that's what process management, requirements traceability does. That's what the good software engineer is responsible for. This almost looks like a critical path chart, doesn't it? But it's really showing the threads on how the coordination between development activities happen. So we go from requirements to specifications. Maybe we split this set of requirements into multiple specifications. We go into design. We go into implementation, a part of it, down different, maybe different products, and then verification. These are the same things we saw in the earlier chart. Okay, that's 4.9. We'll go to 4.10. So, how do we put measurements on requirements? So this is something new. First of all, we focus on three different areas: product, process, and resources. So the number of requirements can give us a sense of the size of the developed system. Lots of requirements, bigger system. Fewer requirements, probably smaller system. Number of changes to requirements. And this is where we want to make sure those changes are made before we go into planning and design and programming, right? But the number of changes, which can happen in a legitimate fashion. This is not the changes that we saw earlier that we didn't want to have happen, unexpected changes. These are changes that we really may cause ourselves because we looked at the requirements and we found conflicting requirements, or we saw things that are too vague. So we're going back to the customers. So we may cause changes. We may go to the management, and the management says no, and I know that they said they wanted that, but we can't afford that. So go back and figure out what you can do to meet their requirements, but you can't do that. So changes to the requirements are going to be an impact on the size of the project, right? Many changes indicate some instability or uncertainty in our understanding of the system. Our understanding can include us and the customer's understanding. Requirement size and change measurements should be recorded by requirements type. So as we go through, we ought to have, remember we wanted to list our requirements by individual requirement, and then we wanted to group them by type. So we're going to keep track of those, and some of those requirement types may have more changes than others. So we can begin to record where we need to concentrate on making sure we know what we're doing. So here's a rating scheme. A number 1 would go to a requirement that you understand completely. You've designed systems similarly, and you have no trouble developing a design from this requirement. That's a number 1. All the way down to number 5, you do not understand this requirement at all and cannot develop a design, right? So it's a spectrum from 1, which you've got that under control, right? Number 2, look, some elements of the requirement are new, but they are not radically different from requirements that have been successfully designed. That won't scare you if you know what you're doing. But as we go down, it gets worse. So we can do a chart that would look something like this. Here is a well-founded project. The number 1s, the ones that we've seen before and we know how to do, that's a huge number of our requirements, right? Some are new, but as we go down, we have very few that are unknown and ambiguous, right? We don't know what to do with. This is a very poor project to start out with. We have very few 1s and 2s, and we have a whole lot down here. We have a lot more work to do here before we're ever going to start planning. Does everybody see that okay? Does that make sense?
Just because you have a large number or a small number of requirements, I mean complexity, don't you need to take into consideration the complexity of each requirement?
Yeah, if this was if you have very few but they're very complex, yeah, you want to worry about that. But what this does is it gives you this area and this area, maybe in particular, you can work on fairly concentrated work. Here, what are you going to do? Most of your requirements are in bad shape.
Yeah, because you may have, let's just use arbitrary numbers for number 1 there. You may have 100 requirements, and they're going to take X amount of time. Well, the 5 more complex requirements may still take X amount of time, the same amount of time that it took to do the 100.
That's correct. That's correct. But before we can even start on these, we need to turn them into those, or maybe this one. They may be all new to us, but what this tells me is this is one where we came away from the customer interview, we did our analysis, we did everything else, and we said, we still have no idea what that means. Okay, that does it for tonight. That's as far as we wanted to go.